All right, the last topic in this chapter is on derivatives of inverse trig functions. So we can use the concept of implicit differentiation to find formulas for the inverse trig functions derivatives. Now, this is a chart that I just found on the internet that shows you the different formulas for them. So one thing I should mention about this is by far the most important formula on this page. The derivative of inverse tangent, or arctangent, is 1 over 1 plus x squared. That's going to come up all the time in Calc 2. So that one is worth memorizing. The rest of these, just know that they're there and know that you can look them up if you need them. But memorize the inverse tan derivative. So I want to do two things in this section. I want to just do an example using one of these formulas, and then I want to show you how to derive these formulas. I might ask you to derive one on a test at some point. So let's just look at using the derivative formula. Find the derivative of arc cosine of x squared plus 5x. Okay, there's not much to this. Just look up the formula for arc cosine. Remember, arc cosine and inverse cosine, they're the same thing. I prefer to use the arc notation because this too many times people confuse that with being the reciprocal when it's actually the inverse function. So let's see, what's the derivative for arc cosine? Let's see, minus 1 over the square root of 1 minus stuff squared. The stuff in this case being x squared plus 5x. Let me write that a little more legibly. X squared plus 5x squared. And then, of course, we've got to do the chain rule. So we've got to multiply this by 2x plus 5. And that's all there is to it. Let's look at something more interesting, though. Let's look at deriving one of these formulas. And I'm going to derive arctan. So derivation of arctan, here's what you do. You start out with y equals arctan x. And we want to find y prime. Okay, well, here's the thing. Take the tangent of both sides of this. If you take the tangent of both sides of this thing, over here you get tan y. And over here, tan of arctan, they undo each other and you get x. So maybe I should make a list of what I'm doing over here. Take tan of both sides. Next up, I'm going to take the implicit derivative. So the derivative of tangent is secant squared, but we're doing this implicitly. We don't we have to multiply by the derivative of y. So we get secant squared y times y prime, and derivative of x is just 1. So now I can solve this for y prime and get y prime is equal to 1 over secant squared y. And we're almost done, but we've got to somehow convert this back into being in terms of x. Now your first thought might be to rewrite this, and honestly, this was my first thought too, is to rewrite it as cosine squared of y, since cosine is the reciprocal of secant. And when I looked at this before I started putting the notes together, and this was my first thought, and I got kind of stuck. But this isn't what you want to do, because what we're aiming for is this formula up here, the 1 over 1 plus x squared. So here's how you can do this. Recall, there's a sine squared x plus cosine squared x is 1. Well, if you take this, there's another Pythagorean identity we can use. If you divide all this by cosine, notice what you get here. This is sine over cosine is tan. So tan squared x plus 1 equals, this is secant squared x. So I can rewrite this as 1 over, replace secant squared with tan squared plus 1. So tan squared of y plus 1. And then notice tan squared of y, well, tan of y is just x. So you get, this is 1 over x squared plus 1, which is what we were shooting for. So we are able to derive that using using what we know about trig derivatives over here for the derivative of tan, and then using implicit differentiation. And you can do that same sort of thing to get the rest of them. Let's do this last example. I'm going to do it in this video as well. We're going to derive the derivative of arc sine. So I'm going to do the same thing as before. I'm going to say y equals sine x. I'm going to take not sine x, y equals arc sine of x. And the goal is to find y prime. Okay, take the sine of both sides. Sine y then is going to be just x. Take the derivative of this implicitly. Derivative of sine is cosine. Derivative of x is 1. So I wind up with y prime is equal to 1 over cosine y. Okay, there's nothing wrong with what I've got here, but I need to change this into this up here. So the way to do that, we're aiming for, let me go back up to it again, we're aiming for square root of 1 minus x squared. So the Pythagorean identity is going to help us again. Cosine squared x plus sine squared x equals 1. So if you take this and solve it out for cosine, you get cosine squared x is sine, or 1 minus sine squared x. And so if you take the square root of both sides, you get cosine of x is 1 minus sine squared x. So I can do that over here and rewrite this as 1 over square root of 1 minus sine squared y. And notice sine of y is equal to x. So we get that. And that matches up with what we had in the table at the top. All right, that's a lot of videos, but that finally concludes this section.